Right, hi everyone. First of all, welcome to S3 Physics, and thank you so much for choosing physics. You're all very welcome, and we look really forward to working with you and can't wait to work with you properly as well. In the meantime, we'll be sending online work and making wee videos like this. So the first one, this is a very important thing about how to present calculations in physics. Calculations in physics are worth normally 3 marks for a normal calculation. And we need to lay the working out properly. So how to do that is, the first step is to write the formula down. Step 2, substitute your values in, and step 3, provide the calculated value with the correct unit. So the first mark is normally for choosing the correct formula and writing it down. In your questions that we've given you, we've been nice to you since this is your introduction to physics, and we've said which formula to use. Normally it would be up to you to choose the correct formula, and that's why it's normally worth a mark in a test. So there we go, that's the 3 steps. So how does that actually work? So we'll go through the solutions to some of your homework questions, and that means you get a wee sneaky look at how to do those questions as well. So question 5, first of all, is about the frequency of waves. The question says, a student is relaxing on Troon Beach and is counting waves approaching the shore. She counts 10 waves in 50 seconds. Calculate the frequency of the waves using our frequency equals number of waves divided by time formula. So there it is there, there's the 3 steps. F equals n over t. Then substitute the values in. F equals 10 divided by 50 because it's 10 waves in 50 seconds. 10 divided by 50 to give you a frequency of 0.2, and we need the unit hertz as well. What we quite often do, which is good practice, to make sure we're choosing the correct formula, is write down the quantities that are given in the question and what we're looking for. So in this case, we're looking for the frequency, so that gets a question mark. Number of waves, capital N, gets 10 from the question, and t is 50 seconds. So just writing that down normally allows us to see which formula we're using. So in this case it would be the frequency, number of waves and time formula, F equals n over t. And you'll always get a wee list of equations. It's not about remembering the equations, it's about taking the list and making sure you use the right formula for the right question, for the right situation. So that's question 5. Question 8 is using speed, distance and time. The question says, let's find it. A water wave travels a distance of 150 metres in a time of 10 seconds. Calculate the speed of the water wave using v equals d over t. So that's just your speed, distance, time formula. Speed equals distance divided by time. You will have done that in maths before. S equals d over t. And in physics we just use a v for speed instead of s, just to be different. But it just means the same thing, speed, distance and time. So it's the distance travelled per second. So speed equals distance divided by time. So in this case, the distance is 150 metres, covered in a time of 10 seconds. So the speed equals 150 divided by 10, and then the speed is 15 metres per second. And ms with a wee -1 above it is how we write metres per second. That's what it means. ms -1 is saying that out as metres per second. In maths you might have done like m/s or something like that, but we tend to use that notation, which is ms with a wee -1 up above it. So again, it's the same 3 steps. Formula for the first mark, v equals d over t. Substitute the numbers into the formula. V equals 150 divided by 10. V equals 15 metres per second. So that was question 8 there. And question 9 says, a sound wave has a frequency of 170 Hz and a wavelength of 2 metres. Calculate the speed of the wave using the formula v equals f lambda. So lambda is a Greek symbol. That's what we use. That's what it's called. It's called lambda. It's a symbol we use for wavelength, and that's a wavelength in metres, 2 metres. So that's the relationship. You can work out a speed of a wave by taking the frequency and multiplying it by the wavelength, and that's the link between the three. So that's a formula you won't be familiar with, but that's what it means. Speed equals frequency times wavelength. So it's the same three steps. Speed equals frequency times wavelength. Sub the values in. Speed equals 170 times 2. Speed equals 340 ms to the -1 meters per second. So that's using that formula there. So that's just a wee quick introduction on how to use equations. The equations are used to predict things, work things out, in order to understand the world around us and through physics. So that's working out the speed of waves, for example, working out the frequency of waves. That's an important skill. Other skills we'll need is we need to be able to change the subject to that those sort of equations, and to solve for example, like working out the wavelength, we'll have to rearrange that, but we'll come to that later. And the other things we need to be able to do is express big numbers and small numbers using scientific notation, and use prefixes like milli and kilo and things like that. But all of that we'll come to, and I hope that's a nice wee introduction, and hopefully that's straightforward enough. If you do have any questions, make sure that you send us a message and we'll help you. We'll get back in touch with you and help you as much as we can, and we look forward to receiving your first bit of work. Good luck.